Okay, hey guys, so this video is going to go over all of the pH calculations for acids and bases. It is really key that you get in your head that the amount of hydrogen ions and hydroxide ions, they fluctuate together. So acids and bases are always dissolved in water. So if you increase the amount of H, the amount of OH will decrease because they're in water. Remember, water is HOH. And then if something has a low pH, that means it's an acid, and it will have a lot of hydrogen ions. If something has a lot of OH, that means it's a base, and it will have a high pH, or greater than 7. And so things that are acids, they have a lot of H, and they do still have some OH, just not a lot. Things that are bases have mainly OH and just a little H. So they are related to one another. If one goes up, the other one, if H goes up, OH goes down. Now you should have this slide in your notes packet. We have 6 formulas for acids and bases. You don't have to memorize them, but this is where you can write them down at. So to keep yourself organized. Okay. And so how to calculate how many hydrogen and hydroxide, which is OH, ions a solution has. This is our first formula. So you'll want to put that into your formula chart. 1 times 10 to the negative 14, which is known as the ion constant of water, will always equal the concentration of hydrogen ions times the concentration of hydroxide ions. Now, these brackets, they're brackets, not parentheses, because they mean concentration, which is molarity. So this is our first formula. So when you multiply H times OH, it will always equal this number. Okay. So our first example problem, we have a solution that has a concentration of 1 times 10 to the negative 3 molarity hydrogen ions. What's the concentration of hydroxide ions? So a lot of people will mess up because hydrogen and hydroxide sound similar. When you see hydrogen, right, that is H plus. Hydroxide is OH negative. Okay, and so we have a concentration of hydrogen ion, and I want to know the concentration of OH ion. We'll use our new formula. 1 times 10 to the negative 14 equals the concentration of H times the concentration of OH minus. So 1 times 10 to the negative 14 equals the concentration of H is 1 times 10 to the negative 3. That is supposed to be a exponent times OH. And to solve for OH, we would divide each side by 1 times 10 to the negative 3. 1 times 10 to the negative 3. So that cancels out. And OH, now be careful typing in the calculator because these are both in scientific notation. So you need to make sure you're using parentheses around your scientific notation. Another thing, when you type this in the calculator, you have to use the negative symbol here, not the subtraction. The negative symbol is that one at the bottom. And when you do this, you should get 1 times 10 to the negative 11. And the unit for these are molarity, because we're talking about the concentration. Now, this problem continues. If my hydrogen ion concentration is 1 times 10 to the negative 3 molarity, if my hydroxide concentration is 1 times 10 to the negative 11, is this solution an acid or a base? And then what would my pH be? So when you talk about negative exponents, this trips a lot of people up. These are negatives. So 1 times 10 to the negative 3 is really 0.001, because remember the negative exponent, that means it's a decimal, and so I'd move it 1, 2, 3. So that's 1 times 10 to the negative 3, which is the H plus. OH then, because it's to the negative 11, would be 10 zeros. And so 10 zeros is going to be I think that's, nope, another 0, 1. That's 1 times 10 to the negative 11, or the concentration of hydroxide. So what is there more of, hydrogen or hydroxide? You should know this number is bigger than that number, so there's more H plus. And if there's more hydrogen than OH, it is an acid. And if it is an acid, it will have a pH less than 7. If there were more hydroxide, it would be a base. If the hydrogen and hydroxide concentrations were equal, it'd be a neutral. And it's only neutral at exactly 7, a pH of exactly 7. This chart is just a nice little summary of that. Okay. Now, our next formula. pH equals negative log times the concentration of H plus. So once you have the concentration of hydrogen ions, you can calculate a solution's pH. Now, the log symbol on my calculators is right underneath the second button. You'll use that. And then this is a negative, not a subtraction. So we have to use our negative symbol again, not the minus sign. But this will let you go from hydrogen ion concentration to pH. So this example is if I have a solution that has a concentration of hydrogen ions, and again, I'm going to write that's H plus because hydrogen and hydroxide are tricky. So the hydrogen ion concentration is 1.2 times 10 to the negative 8 molarity. What's the pH? So pH equals negative log 1.2 times 10 to the negative 8. And then the second part of the question is this an acid or a base? Let's do this first. So go to your calculator, everyone practice typing this in, hit the negative symbol, the log button, and then type that, and make sure you close out your parentheses. And we get a pH is 7.92. And you type that in. And then, is this an acid or a base? pH is greater than 7, so that is a base. We could go, because we have the concentration of hydrogen ions, and use our first formula and figure out how many hydroxide or OH ions there are. Not going to do that, but you can. So you can go from hydrogen ion to pH. Now, there's a pH scale. There is also a POH scale. Surprise! And it stands for power of hydroxide. So this gives a relative amount of hydroxide or OH ions. Hence why it's called the POH scale. And so look at this really fast. This is POH and this is pH. If something has a pH of 0, the POH is 14. So when pH is 2, POH is 12. If pH is 11, POH is 3. And hopefully looking at that, you can figure out pH plus POH always equal 14. And so that is going to be our third formula. Now, something that totally messes people up is the POH scale. Because when you look at this, a POH of 14 is an acid. Versus you've kind of learned since, I don't know, 7th grade, that pH 14 is base. The POH scale exists. I want you to think about in terms of acids and bases, the pH scale. So if I tell you POH is 3, is this an acid or a base? How I want you to think about it is say, okay, if POH is 3, pH is 11, that's a base. If you try to memorize the POH, you'll just mess yourself up, but you do need to know this formula. And so that's 3 of our 6 formulas. Here are the rest. So you should have 1, 2, 3 down. Pause the video and get the rest. These two are exponents, so 10 to the negative POH. And then we're going to do some practice problems together. Okay. So what's the pH of a solution where H plus equals 1 times 10 to the negative 9? So I have H plus and I want to find pH. I go to my formula chart. The only this formula lets me go from H plus to pH, so I'm going to use this one. So pH equals negative log of H plus. pH equals negative log 1 times 10 to the negative 9. Type that in your calculator. I'll give you a second. You should get pH equals 9, and exactly 9. Now part 2, what's the pOH of this? I know pH is 9. Go to our formula list. pH plus pOH equals 14. And so, if my pH is 9, I know they have to add up to equal to 14. My pOH is 5. Boom. Number 3. What's the pH and the pOH of a solution where H plus is 3 times 10 to the negative 3 molarity? And then is this acidic, basic, or neutral? So I want to find pH and pOH. And I have hydrogen ion concentration. I've got a few formulas that I can use. I'm going to use this one first and solve for my pH. So pH equals negative log H plus. So pH equals negative log 3.4 times 10 to the negative 3. Make sure you use negative symbol, negative symbol. And I get my pH is, so let me type that in, 2.47. And then to solve for my pOH. pH plus pOH equal 14. So 14 minus 2.47 will equal my pOH. My pOH equals 11.53. So there's my second answer. This is my first answer. And then the question, is this acidic, basic, or neutral? To determine this, look at pH. Don't look at pOH. And when I look at my pH, it's 2.47. pH less than 7 is acid. Now you got to be careful, because if you jump down, you're like, oh, you saw this one, you might say base, but that's pOH, not pH. Okay. Number 4. What's the pH and pOH of a solution with OH negative equals 8 times 10 to the negative 10? And then is this acidic, basic, or neutral? So this time I gave us the hydroxide, or the OH concentration, and I want us to find pH and pOH. So I can't use this formula because I don't have H, but I have OH, so I'm going to use this formula. And pOH equals negative log OH. So we'll plug that in. pOH equals 8 times 10 to the negative 10. Oops, I should have written negative log that. And then we type that into the calculator. pOH equals 9.09. My pH, remember they add up to equal 14, would be 4.91. And then to figure out if it's acidic, basic, or neutral, I'm going to look at the pH, not the pOH. 4.91 is less than 7. That is an acid. And I want you to try, number 5, really fast. I'm going to help you out, and then pause the video, try it by yourself, and see how you do. So 7.84 molarity HNO3, which is nitric acid. When I give you the molarity of an acid, assume that's your H plus. So my H plus is that. And I want you to try this one on your own, and then you'll check the answer key on the PowerPoint and see if you're right.